Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. In today's video, let us discuss the topic different types of ratios. Here we are going to discuss the various types of ratios and how to deal with them. First type of ratio in math is compound ratio. The ratio compounded of the two ratios A is to B and C is to D is. This is the definition of compound ratio. You just have to multiply the first and third and second and fourth. Does this make sense to you? Okay, let me show you few examples for your better understanding. Here is your first example. For your convenience, I have just named these numbers as AB and CD. Now let us multiply AC and BD. So this would become 15:28. This is how we find the compound ratio of any pair of ratios. Hope this makes sense. Okay, let me take one more example and explain you. In previous example, we just had two pair of ratios, and in this example we have three pairs. So how to find the compound ratio? First, let's find the compound ratio for the first two pairs, 2 times 5 and 3 times 7. Hope you are clear so far. Now find the compound ratio for this ratio and the third one. Same way, multiply the first term with third one and second with fourth one, which will give you. Hope you are clear with this example. So no matter how many ratios you are getting, you just have to find the compound ratios taking the pairs first, second, and the answer and the third one, and the answer and the fourth one. So it goes on like that. Now the second type is duplicate ratio. Duplicate ratio is nothing but a ratio compounded of itself is called its duplicate ratio. You can say that A square is to B square is the duplicate ratio of A is to B. Similarly, you can also say that triplicate ratio would be A cube is to B cube. Let me show an example for duplicate ratio. Duplicate ratio of 2 is to 3 is, just take squares. That's it for this example. Now let us move on to triplicate ratio. A ratio compounded of itself twice is called triplicate ratio. As said earlier, we just have to take the cubes. Triplicate ratio of 2 is to 3 is 2 cube is to 3 cube, which is nothing but 8 is to 27. Hope you're clear so far? Okay. Now let us move on to subduplicate ratio. Now let's see the fourth type. Fourth type is subduplicate ratio. Subduplicate ratio of A is to B is just the square root of A is to square root of B. Let me take few examples and explain you. These concepts may look similar, but there will be slight difference between each of the type. To find the subduplicate ratio of 4 is to 9, we are going to just take the square root of 4 is to square root of 9, which is equal to 2 is to 3. Hope this makes sense to you. So what would be the subduplicate ratio of 16 is to 25? Yes, 4 is to 5. Now let us move on to the next type, subtriplicate ratio. Subtriplicate ratio of A is to B is cubic root. The previous one is square root, this one is cubic root. Let me show you an example. Here are two examples. What is the subtriplicate ratio of 64 is to 125? Just take cubic root. Cubic root is nothing but power raised to 1 over 3. 64 can be written as 4 cube. 125 can be written as 5 cube. When there is power over power, we are just going to multiply the exponents. 3 times 1 over 3. In case if you have any query on law of exponents, you can refer to the video law of exponents. So subtriplicate ratio of 64 is to 125 is 4 is to 5. Same way we can solve the next example. Just take the cubic root of 8 and cubic root of 27. Hope you are clear with these examples. Now let's move on to the next type, inverse ratio. One ratio is the inverse of the other if the product is 1. Thus A is to B is the inverse of B is to A. Same way you can say that B is to A is the inverse of A is to B. We can take few simple examples. 3 is to 4 is the inverse of 4 is to 3. 4 is to 3 is again the inverse of 3 is to 4, vice versa. So therefore you can say that 3 is to 4 and 4 is to 3 are the inverse to each other. Let us try multiplying, because the product must be equal to 1. Am I right? This can be written as fractions. Just cancel out the common factors, so you'll be left over with 1 times 1 in the top row, that is 1, and 1 in the bottom row, which is equal to 1. So you have proved that 3 is to 4 and 4 is to 3 are inverses to each other. Hope that makes sense to you. Now let us move on to the next type, ratio of inequality, ratio of equality. Name itself explains what is ratio of equality. A ratio A is to B is said to be equality if A equal to B. For example, 7:7 is a ratio of equality because 7 is equal to 7. These are the few examples of ratio of equality. Same way, let us see what is ratio of inequality. Just the opposite of ratio of equality. If two numbers are not equal, then you can say that the ratio is ratio of inequality. Definition is a ratio A is to B is said to be of inequality if A is not equal to B. You can give any simple example for this one. The numbers that are not equal to. Hope you are clear with this concept, ratio of equality and ratio of inequality. You can take any example like you can take any different numbers. A ratio A is to B is said to be of greater inequality if the first number A is greater than B. For example, does this make sense to you? Okay, because 17 is greater than 19. You can say that the ratio 17:9 is a ratio of greater inequality. You can assume any number, but the condition is A has to be greater than B. Okay, hope you're clear with ratio of greater inequality. Now let us move on to the next type, ratio of lesser inequality. This type is quite opposite to the previous type. The ratio A is to B is said to be of lesser inequality if the first number A is lesser than B. I'll just write the definition on the board. I can take the reverse of the previous example. Previously I took 17:9, but here I'm going to take 9:17. Please note that the first number 9 is lesser than 17, or you can say that 17 is greater than 9. So this is a ratio of a lesser inequality. Hope this makes sense. Next type of ratio is continued ratio. Continued ratio is the relationship, or you can say it as comparison, between the magnitudes of three or more quantities of the same kind. The continued ratio of three similar quantities ABC is written as A is to B is to C. Ratio for many quantities, three or more quantities of the same kind. I would like to explain the ratio of incommensurable quantities so that it will be easier for you to identify the ratio of two integers that are incommensurable. Okay, let me explain it. If the ratio of two similar quantities can be expressed as a ratio of two integers, the quantities are said to be commensurable. Am I right? Otherwise, if this condition is not satisfied, we can say that the ratio is not said to be incommensurable. Okay, it is said to be incommensurable. Now let me write an example so you'll get a better idea. Please look at this example. I have radicals. Root 3 is to root 2. This cannot be expressed as a ratio of two integers. And therefore we can say that root 3 and root 2 are incommensurable quantities. Does this make sense to you? Let us see an example on continued proportion. Let us assume that the given ratios in the continued proportion are all equal to an integer k. So you can set this equation equal to k. Now let us consider the ratios now one at a time and solve for the variables. Equating the first one, we get this by cross multiplication. Same way, let us equate the second one. Similarly, solve the third one and get a value for z by cross multiplication. So we have got some values for x, y and z. Now let us back substitute these values in the given equation. This is the given equation. Replace x by 4k, y by 3, z by 2k. Simplify it, multiply, combine the like terms in top row. K is the common factor between numerator and denominator, so just cancel it out. 19/9 cannot be simplified further, so this should be the last step. This example explains the application of ratio and proportion. These types of ratios are simple mathematical tools that use ratios to express the relationship between multiple quantities. More often, the knowledge of ratio and proportion is applied together to solve day-to-day problems. One last example on this topic. So far we were discussing the types of ratio and how to find them. But now I have taken an example so that you could identify the number that is not in the proportion. Please read the question carefully. Let the fourth term be x by the definition of ratios being the proportion. So by the definition, I'm going to write this as, now let's cross multiply and solve for x value. Divide both the sides to get the x value. X value is 40. So it makes this clear the fourth term has to be equal to 40, not 42, for the numbers given to be in the proportion. Hope you're clear with these examples. In this grade